Just a quick video to get started with these Julia notebooks and looking at some actual brain images. And so there's probably a couple of things that we need to make sure that work on your computer as well. So I'm on a Mac here, but things should be very similar on a Windows machine as long as you have Julia installed and you have access to the internet. So I'm currently keeping a whole bunch of files together in one place and on Dropbox, which you may be able to see. There's a sort of currently only a little README file which contains some text and some descriptions, and a folder that contains a slightly oddly named file that actually contains some images of brains. So we hopefully will be able to look at that. So I have Julia installed and I can type Julia at the command prompt. So on a Windows machine, starting Julia might be slightly different, right? You might have to double-click an icon in your start bar. And so from now on, things should be very similar between the Windows and Mac. And the first thing I want to do is to set up a new environment so we can make sure that all the sort of additional libraries that you need to run some of the things are installed. So what we're going to do is going to put the open brackets opens up this package manager which allows you to install new things into Julia that aren't already there. So we want to activate this current environment. It's called an environment to make sure that all the things that we add are sort of kept together so that if somebody else wants to open up this project, they can deal with the same dependencies, right? So they can see the same packages. So to do that, I'm going to type activate dot, and you can see it's added a new file called project.something. And if I go into the package manager, you will see that the prompt has changed from this version 1.6 to UON, which is University of Nottingham 2021 Summer Brains, okay, which is the name I've given the folder. So it sort of picked that up. Okay. So if we now add packages here, it will get added to this list contained in the files. So we can then keep track of it for if we want to run it maybe on another computer in another place, or if you want to hand it over to a friend to have a look at as well. I'm going to add the package Pluto because we're going to need that to run the notebooks. So you've probably already tried that, but you may have to redo it. And so that's going to take a minute, and I might pause and come back when it's done. All right, and now we're going to add a couple of other ones as well. So I'm going to add one called images and image magic with a CK. I'll give that a second. All right, so that took nearly a minute, so that's pretty good. And then last but not least, we're going to add one called NIFTI, which has got some weird capitalization. So you can always try tab completing it, so by pressing the tab key, because that will let you know whether the computer actually knows about this name. So it's quite a useful way of checking that your spelling is correct. Okay, so I'm going to do that as well. All right. And so now that we're done, we can try and run the Pluto notebook. So I'm going to have to type using Pluto. And then I'm going to write Pluto run with parentheses. And then that should hopefully pop up the web browser and put up a Pluto notebook, which is what you may have played around with before as well. All right, so I'm going to create a new notebook. So the first time you run this, it takes a little while, but then usually gets more zippy, more quick, because it sort of deals with some of the things the first time around, but then the second time around it sort of remembers it. So technically speaking, it sort of pre-compiles it into a version that the computer can understand. So the first thing I'm going to do is I'm going to make the font a little bit bigger so you can see what's going on. And I will save it. And so I'm in my folder, but I have to give it a name. So I'm going to call it maybe brain-notebook.jl to let it know that it's Julia Notebook. Okay, and so that should be saved and it keeps track of it. And now I can interact with this notebook. And so one thing I want to do is I want to actually use some of these libraries that we've installed. I'm going to say using images and wait for that to execute. You can see there's like a thing on the side going on. It will tell you how long it actually took in seconds. And I can already say using image magic. We also want to use that one. And the final thing we want to do is using NIFTI. So the next thing we want to do is we want to load in this data file that contains the images. Now they're not images like you can open up in Photoshop or some other image viewing program like on your phone camera or something. They're stored in a special format that's used for scientific images, for brain images. And so we're going to use this function that it was included in this NIFTI library to open up the files. And then I will show you how you can actually display the numbers that are stored in that file as an image that we can sort of understand with our eyes. And I'll just do that. I'll walk you through it. And then you have a version of this that will at least work for that particular thing. And maybe as a final flourish, I'll show you how we can make it a little bit interactive, which is kind of cool. And then that's a good starting point to maybe discover something else about this data set that we can talk about in the next video and so on. All right, so I'm going to open a new cell. And what I want to do is I want to remember where the data were actually stored. So over here in this folder, I told you there's sort of a folder called data. And inside that is this weirdly named file called MNI 152, which stands for Montreal Neurological Institute. The 152 means that the image that we're looking at is actually derived from not just one brain, but more than 150. And there's some other numbers which I can explain to you in due course. But for now, all I'm going to do is, so I don't have to retype this, I'm going to copy and paste that text of the file name. I'm going to go back to Julia. So I don't have to remember from off the top of my head what that file name is called. And what I want to do is I'm going to use a function called NIRead, which is NIFTI read. And I have to give it the name of the file that I want to open up. And so that's stored in a folder called data and whatever I just selected here. Okay. Now I want to hold on to the information that comes back from this function NIRead. So I need to store it in something called a variable, right? It's just like a container or something that actually holds on to the data, so I can just call it by a name rather than just sort of referring to it abstractly. I'm just going to call that im, maybe short for image. Okay, I'm going to do shift return, and that's probably going to take a couple of seconds. And when it comes in, you will actually see what the data that makes the image actually is. It's a bunch of numbers, and we'll talk much more about how the data is actually organized and how it sort of refers to an image. But for now, you can just think of any image as a big table of numbers with lots of rows and columns and so on. So this is not very nice to look at, right? Because you can't actually interpret what all of those numbers mean. So what we want to do is we want to turn this big giant table of numbers into something that looks like an image. And so what we want to do first is we want to select out of this three-dimensional image. It's a whole stack of images, one particular slice. And so that's another thing we're going to talk about a lot. And so the way you do that in Julia is you index into this table. You basically say only keep a certain set of rows and columns for a particular slice. And so there's a way of doing that. And maybe I'm just going to say I'm going to take all things along the x and y coordinates in slice 100. And I will explain to you what that means in a little while. And so if I do that and hit that, I basically get a subset of the data in this whole three-dimensional image. but it's still no use to us because it's still being printed as a bunch of numbers. Okay, so I'm now going to do what probably looks a little bit like magic. I'm just going to add some code, and then we'll turn it into something that looks like an image, and I will explain that to you over the next couple of videos, what's going on here. So the first thing I'm going to do is I'm going to divide all of the numbers that come in by 10,000, because I have looked at these images before and I know that the darkest parts of the image are labeled with zeros, and the brightest parts in the images that end up being displayed as white usually, they go up to about 10,000. So if I divide every number in this data set by 10,000, the range of values shrinks down between 0 and 1, which makes it easier for this next step, the library, to actually do the displaying the images. So I'm going to do that. And so I'm going to store the result of that calculation. I'm going to maybe call it, oops, just go back here and call that scaled slice is equal to that calculation. And then the next step, I'm going to convert the scale, every pixel in that scale table, into a number of gray values, which the web browser knows how to display. All right. And when we do that, you can now see something that looks suspiciously like a slice through a brain. Okay. And so the last little flourish that I want to show you here is that this number 100 controls which slice we're actually looking at. So slice number 0 is slice number 1 actually is the bottom slice, so that's the lowest we can go in this particular image. And slice number end, I think it should work, is the last slice. So it's got a special name for that. If we go to slice 140, that's still somewhere at the top of the head. We can control this number if we just make a little slider. So I just want to show you how to do that. So there's a nice little functionality in these Pluto notebooks, which you might have come across. Add bind slice num slider 1 to 100. We have a slider, and if I make in another cell, just put the value of slice num, you will see that it dynamically updates when I pull the slider. Now you can probably see where this is going, right? If rather than asking for number 140 in this particular slice, I ask for whatever the value of this thing is, then whenever I drag the slider, I will get an update of this particular image. Okay? So if I replace 140 with slice num, then I now have an interactive display, a little viewer that allows us to go from top to bottom. And in one of the next little videos, I will show you how we can figure out how high that slider should be allowed to go and how low it should be allowed to go. We can figure that out from the data. But for now, I think this is sort of quite a nice place to stop. Have some fun looking around at some brain images and wonder about how amazing it is that we can actually look inside people's heads without opening them up. All right, enjoy.